Hi students, okay, today in this lecture we discussing the topic is examples on analytic function. Okay, in the previous lecture we completed the definitions of complex variable function and analytical function and Cauchy-Riemann equations and continuity and differentiability. Okay, na? So now some problems on analytical function. The first problem is verify f of z is equal to z square is analytic or not. So how to verify the given function is analytic? Satisfy the two conditions. That is, the given function must be right in the form u plus iv. So and differentiation u and v with respect to x and y or partial differentiation all are continuous and defined at that point, and also satisfy the must Cauchy-Riemann equations. Okay, na? See that first of all. So let the complex variable in the domain x plus iy. Therefore, the given function f of z is equal to z square. So f of z is equal to z square. Z is equal to x plus iy. So x plus iy whole square. That is equal to expand x square plus 2y xy plus iy whole square. So that is equal to x square minus y square plus I into 2xy. So this is a real part function of f of z, and this is the real imaginary part of the function f of z. So this is the u and this is the v. That is equal to u of x comma y plus I into v of x comma y. Okay, na? This is the real part u, imaginary part v. That is equal to u is equal to x square minus y square and v is equal to 2xy, real part and imaginary part. So now finding the differentiation with respect to x and y of u and v. That is equal to dou u by dou x is equal to derivative of x square into 2x, dou u by dou y is equal to minus 2y, and dou v by dou x is equal to 2y, dou v by dou y is equal to 2x. So all are exist, children. All terms are must be exist at, and also observing the equations are satisfy or not. So Cauchy-Riemann equations is dou u by dou x is equal to dou v by dou y. Observing both are equal, children. Dou u by dou x is equal to x and dou v by dou x dou v by dou y is equal to x, equal. First equation. Second equation, dou u by dou y is equal to minus dou v by dou x. So dou u by dou y is equal to minus 2y, dou v by dou x is equal to 2y, and a minus existence, children. Both are equal but opposite minus. So dou u by dou x is equal to minus dou v by dou x. So we are observing here all are polynomials, all values are polynomials and continuous, and also CR equations are satisfied at every point. Choosing the any point here which is exist and already satisfy the CR equation at every point and at every point z. So therefore given function is f of z is equal to z square is analytic everywhere, and every point where the all our functions are exist and continuous and satisfy the CR equations. So therefore that function is analytic at everywhere. Okay, this is one of the example of analytic function. Yeah, next example. Show that f of z is equal to z is analytic at everywhere. So same procedure here. Z is a x plus iy is a complex number. So f of z is equal to z, given function f of z is equal to z x plus iy. So clearly this is a also complex number. X is the real part, y is the imaginary part, which is assumption the function in the term u plus iv. So u plus iv, u is equal to x, v is equal to y. Okay, now finding the partial derivative. Dou u by dou x is equal to 1, dou u by dou y is equal to 0. Okay, na? Dou v by dou x is equal to 0, dou v by dou y is equal to 1. So you have to observing all are constant values and they must be continuous and exist together. All constant function exist and continuous. Now verify the CR equations, Cauchy-Riemann equations So clearly dou u by dou x is equal to dou v by dou y, 1 equal. Next dou u by dou y is equal to minus dou v by dou x, and both are equal 0 kada, choosing the minus. So that is equal to, we observe that all are constants, that is continuous, and f of z satisfy CR equation at everywhere because all are constants kada. At every point all are same, no change. Okay na? So that is called a given function f of z is equal to z is analytic function at everywhere. Okay, is it clear? మనకి ఆల్ ఆర్ అన్నీ కూడా కాన్స్టెంట్స్ వచ్చినాయి కదా, వాల్యూస్ కాన్స్టెంట్స్ వచ్చినాయి కదా, చేంజ్ కావు. కాబట్టి ఎట్ ఏ పాయింట్ వద్ద చూసుకున్నా ఆల్ ఆర్ సేమ్ అండ్ ఈక్వల్. సో నెక్స్ట్ ఎగ్జాంపుల్, show that f of z is equal to z into z bar is differentiable at z is equal 0 but not analytic at z is equal 0. Differentiable అవుతుంది కానీ not analytic అని మనం ప్రూవ్ చేయాలి. ఓకే, సో given function z into z bar, z is a complex number x plus iy, z bar is its complex conjugate x minus iy, that is equal to a plus ib into a minus ib, that is a square plus b square కదా, అంటే x square plus y square. So observing here, f of z is equal to x square plus y square. This is the only real part. The imaginary part is 0. So u plus ib is equal to, where u is equal to only real part given, x square plus y square, but v is equal to imaginary part 0. Okay, now finding the partial derivatives. Dou u by dou x, and ux is equal to x and vx is equal to 0. Uy, dou u by dou y is equal to y, vy is equal to 0. So we are observing here all are continuous at only z is equal 0, not other points, only z is equal 0, all are zeros here, so which is exist and continuous. And CR equation satisfies only z is equal 0, only at a single point z is equal 0 the CR equation satisfies, but at another point, and this is a differentiable only z is equal 0, ఆ పాయింట్ వద్దనే సిఆర్ ఈక్వేషన్ సాటిస్ఫై అవుతున్నాయి కదా. బట్ అనలిటికల్ కావాలంటే కాదు, కంపల్సరీ ఎట్ ద పాయింట్ 0 ఎట్ నైబర్హుడ్ ఆఫ్ 0, బట్ ఎట్ నైబర్హుడ్ ఆఫ్ 0 సిఆర్ ఈక్వేషన్స్ ఆర్ నాట్ సాటిస్ఫైస్. అవునా, ఇట్ ఓన్లీ సింగిల్ పాయింట్ 0 బట్ నాట్ ఎట్ ఎవ్రీ నైబర్హుడ్ ఆఫ్ z is equal 0 is not satisfy the CR equations. So is not analytic but differentiable. The differentiable మనం వెరిఫై ఓన్లీ సింగిల్ పాయింట్తో వెరిఫై చేస్తాం, బట్ ఎనాలిటిక్ ఫంక్షన్ ఎట్ ద పాయింట్ సింగిల్ పాయింట్ అండ్ నైబర్హుడ్ ఆఫ్ గివెన్ పాయింట్. సో ఎట్ ద నైబర్హుడ్ ఆఫ్ z is equal 0 is not satisfy the CR equation, so that is not analytic. Therefore given function is differentiable at 0 but not analytic. Okay, yeah, next example, show that f of z is equal to xy plus iy is continuous everywhere but it is not analytic. So that already given, directly given function u plus iy, sorry u plus iv, that is equal to x plus xy plus iy is equal to u plus iv. U is equal to a, now assumption one point z naught. So z naught is a point in the domain x naught plus iy naught, and x naught comma y naught is a point in the organ plane. So that is equal to f of z, the function value of f of z at z naught. F of z naught is equal to x naught y naught plus iy naught. This is the function value at the point z naught. Okay na? Now finding the limits. So limit at the point z naught, limit z tends to z naught f of z equal to limit, the z is equal z naught means z is the x comma y, z naught is x naught comma y naught kada, and x tends to x naught, y tends to y naught of f of z. So f of z plus x plus x naught, y plus y naught, so that is x naught y naught plus iy naught. So which is equal to function value kada. So see that f of z naught and a function limit value, the limit is equal to the function value. Okay na? So therefore given function is continuous. Okay, now verify is not analytic or not. So here u is equal to xy, v is equal to y. Now finding partial derivatives, ux is equal to y, uy is equal to x, vx is equal to 0, vy is equal to 1. See that here? So the CR equations are dou u by dou x is equal to dou v by dou y. Children, is not equal to, ux is not equal to vy, and uy is not equal to minus vx. With x is 0 kada, so not equal. And the CR equations are not satisfied, therefore given function is not analytic. So that is CR equation not satisfied, therefore given function is not analytic, but which is a continuous. Okay. Yeah. Next problem. If w is equal to log z, then determine w is analytic or not. If it is analytic, and find f dash of z. So your given function, complex variable function is w is equal to log z, and f of z is equal to log z. So now we have to prove in polar form. So Cartesian lo తీసుకోవచ్చు, no problem. Z is equal to x plus iy గా తీసుకోవచ్చు, but it's a lengthy procedure, the different form. So if using the polar form in analytic function, they were getting the easily. Okay na? In the polar form, so polar point is z is equal to r into e power I theta, that is r into cos theta plus I sin theta. This is a point. So that is equal to w is equal to a log of z is equal to point is r into e power I theta. So is the in the properties of logarithm, log ab is equal to log a plus log b kada, ante log r plus log e power I theta. So log r plus ikkada base e kada, e power I theta ante the front of the log I theta, I theta into log e base e. Log e base e is the I theta. Okay, that is log r plus I theta. This is the w is equal to. So in the polar form, this is the u plus iv kada. U is a function of r comma theta, v is a function of r comma theta. So that is equal to u plus iv. U is equal to here real part log r, v is equal to imaginary part theta. Okay na? Now finding here partial derivative with respect to r and theta. Dou u by dou r is equal to 1 by r, and dou v by dou r is equal to 0. Dou u by dou theta is equal to 0, dou v by dou theta is equal to 1. So which are continuous everywhere, because 1 by r, 1 by is also number kada, constant. So except 0. If r is equal to 0 is not defined kada. So except 0, all values are continuous. Next to CR equation verify. Dou u by dou r is equal to 1 by r into dou v by dou theta. This is the first CR equation. Equal. Question. Dou u by dou r is equal to 1 by r into 1. 1 is equal, which is can write dou v by dou theta. And dou v by dou r is equal to here 0. So 0 into which is can write minus 1 by r into 0 రాసుకోవచ్చు మనం. 0 is equal to, అంటే minus 1 by r is equal to here dou u by dou r. అవునా? minus 1 by r, అంటే 0 is equal to u by dou theta నే కదా. So dou v by dou r is equal to minus 1 by r into dou u by dou theta. So which are also satisfy the CR equations. CR equations satisfied everywhere except to r is equal to 0. At every point r, but except 0. So given function is okay. Except r is equal to 0 kada, ante r is equal to 0 ante z is equal to 0. So that the given function is analytic everywhere except 0. ante 0 point వద్ద కాకుండా at every other point is must be analytic function. If z is equal to 0 is not analytic. Okay na? Everywhere is the function is analytic except z is equal to 0. So is analytic, and finding f dash of z is the differentiation of f of z. Directly we have formula in the polar form, that is equal f dash of z is equal to a r by z into dou u by dou r plus I into dou v by dou r, that is equal to r into z is equal to point r into e power I theta. Okay na? Dou v by dou r is equal to, here finding 1 by r plus I into dou v by dou r is equal to 0. So that is equal to r by r into e power I theta into 1 by r. R cancel 1 by r into e power I theta is equal z కదా, అంటే 1 by z. చూడండి f dash of z is equal, differentiation is 1 by z, అదే కదా. w is equal f of z is equal log z కదా, differentiation of log z is 1 by z except z is equal 0. Okay. Yeah, this is some problems on analytic function. For more videos, please do subscribe my channel, like and share it. Thank you.